Today we want to take a little time to talk about pulleys, also called Atwood machines. When you're solving pulley problems, there are three main things you want to be able to do. You want to be able to find the net force acting on your system, find the overall acceleration of the system, and then find the tension that's in the rope of the system. So let's start by looking at a problem. Here we have a pulley system that has two masses on it, 5 kilogram mass on the left and a 3 kilogram mass on the right. We're still always going to start by drawing our force diagrams. So each of the masses has a force of gravity pulling it down, and each of them has a tension force from the rope holding it up. Next, you have to decide which way you want to make positive. We're going to change. We're not always going to make up positive and down negative now. We want to think about how this system is going to move. So by looking at this system, I know that 5 kilograms has more mass than 3 kilograms. So overall, this 5 kilogram mass is going to move downward, and the 3 kilogram mass is going to move upward. We're going to define our directions as either clockwise or counterclockwise. In this case, since the 5 kilogram mass is going down and the 3 kilogram mass is going up, I'm going to call counterclockwise as a positive direction. Once you've decided which way is positive, you want to extend that and label all of your forces as positives or negatives based on whether they go in this counterclockwise direction or against the counterclockwise direction. So since this force of gravity goes clockwise and this force of tension goes in the clockwise direction, those are positive. The other two go against the counterclockwise direction, so I'm going to make those negative. Let's think about those tensions for a second. Both of these tensions are connected on the same rope. So do you think they're going to have the same value or a different value? Since they're the same rope, they have to have the same value. So in our equation, this one is going clockwise, and this one is going counterclockwise. So one is positive, one is negative. They're going to cancel out. We also have to remember that both of our masses together make up the system mass. Our system is now this whole thing. Okay? So another way to look at this is to remember that Newton's first law said that objects at rest or in motion will stay at rest or in motion unless acted upon by an outside unbalanced force. If our whole system is both of these masses and this rope, the tension forces are currently internal to the system, so they are not external forces. So we wouldn't want to count them when figuring out our net force on the whole system. So the forces that are acting on the whole system are just these two forces of gravity, which we can write our equation out for that and start solving for our values. 49 newtons for the 5 kilogram mass, 29.4 newtons for the 3 kilogram mass. When you plug them into your equation, you have to make sure you put in this negative value for the 29.4 newtons, because that was going in the clockwise direction, and we made counterclockwise positive. So our net force on this system is 19.6 newtons. First answer. Now we're going to take that 19.6 newtons and use that to figure out the acceleration of the system. Again, we have to remember that both masses make up our system. So we have to add them together and get a total mass of 8 kilograms. We plug that into our net force equals mass times acceleration equation, and you get an acceleration of 2.45 meters per second squared. If I look at that number, it makes sense because it's a positive value, and we decided to make counterclockwise positive. So since they match, the 5 kilogram mass is accelerating downward at positive 2.45 meters per second squared, based on how we just defined positive as counterclockwise. Now, to find tension, we're going to only take a look at one of the masses, either the 5 kilogram or the 3 kilogram. When you're just looking at one of these masses, you want to totally ignore the other one. So we still only have two forces, our tension force going up and our force of gravity going down. I'm going to keep the sign values that we assigned before when I set up my equations. Let's take a look at that 3 kilogram mass. For the 3 kilogram mass, I'm going to use the acceleration that we found, 2.45 meters per second squared, on that mass and get a net force of 7.35 newtons. So 7.35 newtons causes this 3 kilogram mass to accelerate upward. Now let's write our other net force equations, our sum of forces. Acting on the 3 kilogram mass is this force of tension upward and this force of gravity downward. So if I write out that equation and plug in the values that I know, I can solve for my force of tension. Again, my force of gravity has to be negative. This 7.35 newtons has to be positive. It's going in that upward direction, that counterclockwise direction. So I can solve for the force of tension. I get 36.75 newtons. Do you think that's going to be the same for both of them? Well, we already said that since it's the same rope, they should have the same tension, but we can prove it. If we use the 5 kilogram mass, we get a net force of 12.25 newtons. If we go ahead and write our net force equation just for the 5 kilogram mass and plug our values in, we get a value of negative 36.75 newtons. It's a negative force tension here in the 5 kilogram mass because it's going in the counterclockwise direction. When you're solving for your tensions, one of them is going to be positive, one of them is going to be negative because they're going to be going in opposite directions. As long as they get the same magnitude of force, you've done your work correctly. It's a good way to check your work. To summarize, to solve pulley problems, you first want to find the acceleration. To do that, you find the net force on both by using the force of gravity values only. The tension forces are internal to the system. Make sure you use the total mass. Once you have the acceleration of the whole system, apply it to one side to find your force of tension. Use your mass, one mass, and the acceleration to find the net force on one side, and then write your net force expression to find the force of tension.